Good. Okay, Andy. Good morning, everyone. So, online students, can you hear my voice? Say yes or no to me once. Right. So, yesterday, I introduced one more model known as Lambda. Let me repeat it. What has been happened yesterday for 5-10 minutes once. We are concluding today anyway. Relations in Java are categorized into three types. One is references, the concept, one object holding reference of another object. Advantage, the methods of one object can use the members of another object. Means object to object access available in references concept. That is the first one. Second one, inheritance process, where we are interlinking two classes with extends keyword. Advantage, the members of one class directly available to another class. Definition, the process of extracting features from one class into another class. We call it as inheritance process. This inheritance process available to you in 5 ways. Single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So we done all the models related to single inheritance, we done it. Whenever we want to perform multiple inheritance using classes, author not given permission to us, he given error in syntax. The reason the author given to you, whenever we try multiple inheritance using classes, replication of programming components will come. When the replication of programming component comes, it raises some ambiguity internally or confusion internally and generate wrong results, the author said. But according to object-oriented programming language, it has to support multiple inheritance. Because of this reason, author given one component known as interface. Then I introduced interface concept to you. Using interface, all models we done. Interface can hold variable, method, concrete method scheme. It cannot hold blocks and constructors. Interface can be extended from another interface like this. Interface details has been given to you. Still, I not revealed what is the advantage of interface. I not revealed. So 3-4 students asked me a question, but I not answered them. I not answer because I'll show the example what is the advantage within 1 or 2 sessions. I'm going to show it. Means next coming units interface based will be there. That interface based chapters are the examples and advantages. Because I not written advantage of interface, but I introduced interface component to you. Then I said using interfaces you can perform multiple inheritance process. You can perform. There are 3 models available in multiple inheritance using interfaces. A class can be implemented from more than one interface at a time. Class can be extended from one class, can be implemented from any number of interfaces. Second model, one interface can be extended from any number of interfaces. Like this, 3 models available, I said. There I stopped your interface concept there. Then I took abstract class. Why I took abstract class means whenever you completed class and interface, you must complete the seventh alphabet. That is abstract class. Class declared with abstract keyword. We call it as abstract class. Abstract class speciality. It can hold concrete methods and abstract methods. But we cannot instantiate abstract class. We cannot instantiate interfaces. That's the informations to you. There I given. So abstract class examples also available somewhere. Then I revealed one concept known as generalization. I revealed. Do you remember generalization? Right. First, normal inheritance means child class OB is equal to new child class. Implementation class OB is equal to new implementation. Extension class OB is equal to new extension. Three models means class, interface, abstract class. Generalization. Parent class OB is equal to new child class. Interface OB is equal to new implementation. Abstract class OB is equal to new extension. These are the generalizations. After this generalization completed, generalized object means one object created holding all the members of parent and overriding members from child. That is the concept of generalization. There we stopped and gone for your inner class concept we entered. This is important. The process of declaring one class inside the class, we call it as inner class, or you can say nested class. You can say inner class, or you can say nested class. These inner classes, two types to you: member inner classes and anonymous inner classes. Member inner classes means names will be there. Anonymous means name not there. So two types: inner classes with names, inner classes without names. Instead of writing that statement, I written member inner classes and anonymous inner classes. The classes which are declared as members of class, you can call it as member inner classes, categorized into two types again: static and non-static. The inner classes which are declared with a static keyword, we call it a static member inner class. Static member inner class diagram is there for you, visual. The static member inner class will get the memory within the outer class diagram, and there is no relation between the objects. There is no relation between the objects. When there is no relation between the object, members of inner class cannot access members of outer class. I made a coding rule to you. Instance method of static member inner class cannot access instance members of outer class. I made a statement. Object creation syntax. Outer class name dot inner class name OB equal to new outer class dot inner class. Then I brought non-static member inner class, two types to you. One is instance member inner class outside the method, local member inner class inside the method. The non-static member inner class which is declared outside the method, we call it as instance member inner class. In instance member inner class, there is a relation between the objects, which means inner class object is holding reference of outer class object. When inner class object is holding the reference of outer class object, the instance method of instance member inner class can access all the members of outer class directly. Theoretically is there and diagram is there. Their object creation syntax is very important to you. Outer class name dot inner class name OB equal to outer class object name dot new inner class name. That syntax you have to by heart it. Then I brought your inner class inside the method. We call it as local inner class. Local inner classes declared inside the instance method will act like a instance member inner classes. The inner classes inside the static method will act like a static member inner classes. The coding rule, wherever the inner class declared means local inner class declared, there only local inner class object also created. That's the information to you. Then after I gone for anonymous. So the class which is declared without name, we call it as anonymous. Anonymous local inner class means inner class declared without name. We call it as anonymous inner class. These anonymous inner classes, two models are there. Extension class without name, implementation class without name. So second model is important. Implementation class without name. The syntaxes you have to by heart for interview. Okay, right. Parent class OB equal to new parent class, open floor bracket, semicolon. Intraface OB is equal to new intraface, open floor bracket, close bracket, semicolon. That syntax you have to by heart. So there is one implementation class without name. So implementation class without name is model modified from generalization of interfaces. Implementation means anonymous inner class as class extension model came from your generalization from classes. It's a theoretical. Later on in Java 8 version, that anonymous inner class as implementation class modified as lambda yesterday. Lambda expression means the process of declaring one method without a method name, means only parameter list will be there. These are all sequence, because I said core Java is a sequence. All are linked, interlinked only they'll come. Parameter list followed by body will be there. So here parameter list followed by body. This lambda expression we are going to attach with one abstract method. Yesterday I drawn the diagram, no? Yes or no? Na? Yesterday's diagram you understood because I not given any assignment. I asked you to watch the diagram and come. So the lambda expression attached with the body of abstract method. And one more new visual for you. Yesterday is nothing but lambda expression executes local to the method where it has been declared. That point you should remember. Major advantage, dot class file will not come. Whenever if you use lambda expression, dot class file will not come. When the dot class file is not there, automatically loading time, linking time of your execution process is saved and high performance will come out. It's a theory. And one coding rule especially, the interface which is providing abstract method to hold lambda expression, the interface must be functional interface. Functional interface means single abstract method interface. It's a theory. Finally, interfaces are how many types available to you now? 3 types. What are they now? Normal interface, functional interface, and marker interface. Marker interface means no methods. Methods are not available. Yesterday I written one definition, methods not available. Somebody from online asking a question. Can I write a default method? Can I write the concrete method is asking a question to me. Somebody from online, cross check it. Interface which is declared with 0 methods. Declared with 0 methods means nothing is there. My intention. I can write without methods if not. Without methods is known as what now? Marker interface. Simply you can say empty interfaces. These two are examples of marker interface. Functional interfaces, these are the examples. And normal interfaces. These are all chapters for you. The coming chapters there. Collection, one chapter. Map, one chapter. Part of collection only, this 6 will be there. Ending 2 chapter. All interfaces are waiting for you. Because I not written any advantage about interface. All coming chapters will be depending upon interfaces. I made a statement already to you. You got eligibility for advanced Java already. Who can start 5:30 batch today? Hope today only. You can start 5:30 batch. You can start it. Somebody is saying Oracle available. You speak to the management once. That Oracle batch you can change it or not. Something options will be there. But my suggestion, take advanced Java. Somebody is asking my batch. I also don't know when my batch will come. So if you want to inquire from management, you can inquire it. They'll give a time to you when my batch starts. But at present, they started one batch. You got eligibility as a core Java trainer. I brought you eligibility for that batch. As a trainer, I brought you eligible for that batch. Okay, right. Right. Note. Today's class is I'll write one more program with lambda for you, re-explaining, and one assignment I'll give it. Okay, right. After that, I'll go for conclusions, inner class conclusions. I'll go. Right. Sir, where to use anonymous inner classes and where to use lambda expressions? For normal interfaces, we use anonymous inner class as implementation class. For normal interfaces, we use anonymous inner class as implementation class model. For normal interfaces, we use anonymous inner class as implementation class model. Normal interfaces means more abstract methods available. If any normal interfaces are there, for them you can write anonymous inner class. Single abstract method is there, you must write lambda expression. For functional interfaces, we use LAMBDA, lambda expressions. We use lambda expressions. For functional interfaces, we use lambda expressions. If it is a functional interface, you must use lambda. If it is a normal interface, you must use anonymous in the market. Okay, right. Now, I written one program for you, comparable. One program I written to you, I'll modify it. See there. Lambda expression. I took anonymous, I think. Anonymous. Right, this one. Comparable concept is there here. I'll copy it. So lambda expression 2, I am taking project application. LAMBDA lambda expression 2. Comparable. I pasted here. Demo LAMBDA. lambda expression 2. Right. See there. I comparable one functional interface, access and demo lambda. This is functional interface anyway. Only one abstract method, no? Right. Access. Here I am using anonymous. This is anonymous, no? Yes or no? No. All of you can observe this code, right? Moreover, I not given definition about this switch case. I not given. Okay, right. Today I'll give it. Now here, I want to make this anonymous inner class as the lambda. Lambda means this one, compare to method. Can you see this compare to method? This compare to method without name. Put one arrow. This is lambda. This lambda. Here new comparable. You remove it. And you remove this colon. This is lambda. So directly we are passing this lambda as parameter. This is lambda. Now compare to, you remove it. Lambda. From here to here, this is lambda and semicolon. This is lambda. Now this is one object creation. Yes or no? Na? This is one object creation. So yield the object and return it. The point. So advantage, same program available in anonymous inner class, but there two dot class files will come. In anonymous here. Here two dot class files will come. The same program only, dot class files. But here dot class files will not be there. Dot class files will not come. That is a major advantage. This is a program. You can run it. It will run. Remaining changes not available. You can run it. Enter the value. It is not affecting the logic. So internally what happens means execution time will be very less and the application performance will be very high. If you use anonymous inner class, execution time increases because the dot class file must be loaded. Here, dot class file loading not there because objects, dot class file not generated and loading and linking not available. High performance will come. So see the code once. This is iComparable interface. For this interface, for this method, I want a body. We are providing. If you say choice 1, I'll provide the body, greater logic body. If you say choice 2, I'll provide smaller logic body. I'll provide it. The point. So this is, but here I am using return switch. It's also new concept only for you. Okay, right. Make it example program. Convert iComparable application into LAMBDA lambda expressions. Lambda expressions. Under P1, I took I comparable. Under P1, I took access.java. Under P2, I took a demo, LAMBDA, lambda expression, to dot class, to dot Java. This is one main class. Right. Right. All of it done it. Right. So watch this model, that anonymous inner class only with lambda. Okay, right. Now this one. Sir, here we are using switch, return type switch. We are using. Sir, I want to know what is this return type switch. Make it FAQ. Define return type switch. This return type switch introduced by Java 17 version. Generally, the trial made in Java 15, 16, the syntax is allowed, but they are not LTS products. No, we write it as 17. Okay, right. Return type switch. Return type switch introduced by Java 17 version, and which evaluates result and returns the result. Result in the sense some calculation, evaluates and returns the result. Which evaluates result and returns the result. A result means I want to send one object. If not, I want to send one value. Anything. You can generate that and you can return it. The syntax will look different. RETURN, return switch and choice, and open flower bracket, closed flower bracket, semicolon will be there. Case 1. YIELD, yield. Yield some expression or result, you can say. Right? Okay. So here, yield some value. They write it as statements. Some statements. Case 2. YIELD, yield some statements. Dot, dot, dot. N cases you can write. Y-I-E-L-D, yield, some statements. So default, some statements, Y-I-E-L-D, some statements. Sir, why semicolon here means the result will be coming out. So result will be coming out. The result. Draw one box for it and keep it. Draw one box. Sir, what is that yield? Y-I-E-L-D. Yield, specify. 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 2. Evaluate. To evaluate statements and return result. Return result. Yield, specify, evaluate statements and return result by stopping the switch. The switch will be stopped. Break not needed. It only will stop. Yield means stopping the switch. Means one expression that whatever the statements it evaluates and one return will come. Sorry, one result will come. It returns the result by stopping the switch. Switch will be stopped. Stop the switch and returns. So in the return type switch, default is mandatory. In a normal switch statement, default not mandatory. Yes or no? In normal switch cases, default not mandatory. If you don't write default also, error will not come. But here, default is mandatory here. In return type switch, default is mandatory. Default is mandatory. Return type switch, default is mandatory. Mandatory means if you don't write, error will come. It's mandatory. Right. All of you understood these statements. At least you must know there is one return type switch is there. Especially your other introduced return type switch for lambda. This kind of syntax. Because lambda is one expression actually. Here one answer will come. You can return it. Except for lambda only they brought it. Actually this switch they brought for lambda. Here concrete methods also for lambda only they brought. That all because of lambda only remaining all features came. So if you want to write the syntax like this, you can write it. It's a point. So all of you understood this syntax of return type switch. All of you understood lambda here, right? Okay. Now, same pattern, I given one assignment to you on the day. Add, subtract, do remember? Right. So the same assignment you must write with lambda. The same thing you have to reconstruct. Construct application to perform operations using lambda expression. Lambda. Lambda expressions. Same names, arithmetic, access. You take demo lambda, lambda expression. Lambda expression 3, I think. Main class. All of you done this program with anonymous? How many of you done? Raise your hands. Anybody? Right. Now you try with lambda. Who completed? Both you must practice. You must know both for the market. You must know anonymous. You must know lambda. Both models are available. Whenever the normal interface is there, anonymous will be there. Functional interface is there, lambda is there. So both are available in the market. Both you must know. right? So by seeing the above program, try this once again. Okay, right. Okay. Now with this, one more 8 feature keep. Make it method references in Java. This also Java 8 new feature. Method references in Java. This also Java 8 new feature. Right. Look here. The concept is like this. Method references, new concept. One functional interface we are taking. We are taking one functional interface. Always I'll take ITest. One abstract method, wide display of int k. Functional interface means one abstract method will be there. Now, here one class will be there. One normal class is there here. Class. Class name is display. This class is holding one constructor. One constructor. One instance method. Void m1 of int y. One instance method. One static method. Void m2 of int z. One static method you had it. So one constructor is there, one instance method is there, one static method is there. This is constructor. This is instance method. This is static method. This is constructor. This is instance method. This is static method. So 3 methods. And there is no relation between these 2 components. They are not related. They are independent. So there is no relation. So link not available. Now the concept is the display method needs body because it is abstract method, no? Right. The display method needs body. Lambda expression means directly you can write the body. So you can write ITest OB and int k, open flower bracket, closed flower bracket. Body will be ready. But here, don't write the body. You take the body of constructor and attach it. You take the body of instance method and attach it. You take the body of static method and attach it. That concept known as method references. Already existing bodies, we have to attach it. That process we call it as method references concept. The definition, make it. The process in which abstract method of functional interface, the process in which abstract method of functional interface is attached with the body, attached with the body of method from a class. The process in which abstract method of functional interface is attached with the body of method from a class, where class is not related to interface, where the class is not related to interface, is known as method reference concept. The process in which abstract method of functional interface is attached with the body of method from a class, where the class is not related to interface, is known as method reference concept. All have understood this definition, right? Now, these method references are categorized into three types. You can take the body of constructor, you can take the body of instance method, you can take the body of static method. Make it method references. Method references are categorized into three types. Method references are categorized into three types. Reference to constructor, reference to constructor, reference to instance method, reference to static method, reference to static method. Reference to constructor, reference to instance method, reference to static method. It is a new concept. Taking existing body and binding. It's a new concept. Make it. The process, reference to constructor. The process in which abstract method of functional interface is attached with the body of constructor, attached with the body of constructor, is known as reference to constructor. The process in which abstract method of functional interface is attached with the body of constructor is known as reference to constructor. Now, syntax. Right, look here. You don't write, I'll be writing. You must take functional interface name OB equal to. So example functional interface today, I test OB1 equal to general lambda expression. You will write like this. Yes or no? Na? So general lambda expression we write like this. So it is directly body attached. But today I want the body of constructor. Constructors are constructor is executed while object creation attached with a new keyword. Do you remember the statement what I given to you? Yes or no? In constructor chapter, constructor is a method having the same name of the class executed while object creation process, because the constructor call is available in object creation syntax attached with new keyword. New keyword is there means constructor will run. So constructors are referred by new. New means constructor. Now, okay. New means constructor. The constructor is coming from where? This operator is scope. Scope means where that constructor is available. You must write the class name. So the constructor available from which class name? What is the class name I took here now? Display. So what is the syntax here now? Class name, scope, and new. This is the syntax. This is example. All of you understood this? Says or no to me? Right, write it. Right. The same way, second one. Reference to instance method. Same type of definition. The process in which abstract method of functional interface is attached with the body of instance method. Body of instance method is known as reference to instance method. Reference to instance method. Syntax. Now, instance method available in the class, available in the object. Instance method memory is in the class, memory is in the object. Object. So, scope is object. Scope means where it is available. Scope is object. So, we write functional interface name OB is equal to object name scope method name. You must write that method name. You want to take the body of which method? The method name you must write. So, example, first you have to create object for display. If you create object for display, display object will come. Using the display object, I test OB2 is equal to tscope M1. M1 is the instance method name under the scope of D. D means object. So you have to create object for class first. Whenever you create object for class, so object will hold the memory for M1. Then you can take the body of M1 and give to the method of your iTest. Then reference to static method. The process in which abstract method of functional interface is attached with the body of static method is known as reference to static method. To static method. Syntax. Functional interface name OB is equal to your method is in the class. Scope is class. Class name scope. Method name. Example, I test OB3 is equal to class name is display scope M2. Method name body of M2. Right. Somebody is asking what is M1? What is M1 and what is M1 here? Method name. Method name. Because you want body of M1, you want body of M2, you must say the method name. Here the information available here, no method name. Method name. Okay, right. Now, example program. Right. Let me write the program and parallelly let me draw the diagram also parallelly. Okay, right. Let me finish out the diagram. Right. Look here. So here I am taking method references concept I am taking. Application method references. Application related to method references. Package P1 and package P2. Under P1, I am taking interface, that is iTest. Holding one abstract method here. So public abstract void display of int k. I'm taking one class under P1. The class is display. I'm taking. I'm declaring one constructor here. Public display int x. Constructor body. Value x is equal to plus x. So this is constructor body output anyway. Constructor body output. I'm taking one instance method void m1 of int y. I'm taking. This is instance method body. Instance method body. This is y. So public static void m2 int z. This is static method body. Static method body. This is z. Like this, three components declared. Now we are taking the body of constructor first. Okay, right. Go for main class under P2. Here. Demo. Method references. Import. P1 dot star. So here first iTest OB1 is equal to class name display scope new, means reference to constructor. Now this is a syntax. The first syntax, no, this one. In this first syntax, what happens? See there. So here, one object created. New operator, one object created here. like lambda expression only. Here, instance method will come. Void display of int k. This will come. That abstract method came. It needs body, no? Right. It takes the body of constructor. It brings that body here. Whenever it brings the body here, it will become int x. The body will come. This is constructor body. The constructor body is attached. All of you understood this? The constructor body attached. So whenever I say OB1 dot display of 111, I'll say. Whenever I say OB1 dot display, if I say, here display is holding the constructor body, no? Constructor body will come out. Whenever I say OB1 dot display of 111, the constructor body output will come. So that is the proof to say that method is attached with the body of constructor. Whenever I call the display method, the body of constructor is coming. Means what? Display method internally attached with the body of constructor. So this 0x2 is the reference for constructor. Means that address is acting like a reference for constructor. That's the meaning. Now, go for instance. Instance means first you have to create object for display. So why we have to create object for display? Because if object create only, method will get the memory. So this is one constructor call directly. This is one constructor call directly. Yes or no? So that constructor will run once again. Again, the constructor is running or not now? This one is running with the display method. This is running normally. Here, constructor. So here one object created. So for this syntax, one object created. Sir, here one object created. Sir, here one object created. Here M1 method will get the memory. Void M1 of int y. Get the memory. This M1 method got the memory. Memory is available here. Now I am using this syntax. Means I want the body of M1 available from D. That's the meaning, scope. So here, one object created. Now, instance method, void display abstract method will come from interface. This method will come from here. And this body will come from here. This M1 body is coming. Why means you said, I want body of M1, which is under the scope of D. You said the address location or not now? The body will come. So here, int y, the body will come. So this is body of instance method. Body of instance. Right. Whenever we say OB2 dot display of 222, then body of instance method is executed. OB2 dot display. Display method here attached with the body of instance method. So whenever I say I test OB2 is equal to dscope M1. This is reference to instance method. Reference to instance method. OB2 dot display. So instance method body will come. Understood this? Right. Okay. The last one. Display, not display. Sorry. I test OB3 is equal to, I want the body of M2, which is under the scope of class. So this is reference. Reference to static method. Reference to static method. Like this. The last one. Here we are drawing reference to static method. We are drawing. Zero x 5. Now void display of int k. The body is coming from here. Body of static method. OB3 dot display of 333. Understood? No? Right. Now here OB3 dot display of 333. So the answer is coming. All of you understood? References, method references, right? Method references means abstract method of one functional interface is attached with the body of method from a class where the class is not related to interface. We call it as method reference concept. 3 types available to you. Reference to constructor here in the diagram. Reference to constructor. Reference to instance method, reference to static method. Write it. So this is the output. Here under example, I took P1, I took iTest.java. P1, I took display.java. P2, I took demo method references dot java. This is one main class. followed by one diagram will be pasted. This is method references. Lambda expression means writing the body for one abstract method directly. Method reference means taking existing method body and attaching with the abstract method. Two concepts and two models you had it. Okay, right. Right. Here assignment not needed. We are going to use its method reference in threading chapter directly. In multi-threading chapter, we are going to use it. So this concept, review it once. Method reference, moreover, 8 feature. Whenever you are practicing Lambda, there only you should look into method references. You have to look it. This is 8 feature and this is also 8 feature. Okay, right. Okay. Now finally, look here. Right. Finally, the classes came inside the class. Yes or no now? So class can hold variable, class can hold method, class can hold constructor, class can hold blocks, class can hold one class also. So when the class is available inside the class, then why don't you declare one class inside the interface? The class is coming inside the interface. The class is coming inside the abstract class they are entering. Right. The classes what we declare inside the interface, they are automatically static. They are automatically static. Whatever the classes you declared inside the abstract class, that can be static, that can be non-static, like classes. Can be static, that can be non-static. Right. Now make a heading. Inner classes in interfaces. Make it. Inner classes in interfaces. We can also declare inner classes in interfaces and which are automatically static member inner classes. We can also declare inner classes in interfaces and which are automatically static member inner classes. Which are automatically static member inner classes. Automatically static member inner classes. Which are automatically static. Static member inner class object creation very easy. Yes or no? Na? Louder, voice not coming. Yes or no? Right. Because this I am concluding. After that, batch conclusion only. Remaining all applications will come. Models over I said already. Okay, right. So you can Why object creation easy means outer class name dot inner class name OB equal to, you can declare. So next one, star mark IMP, inner classes in abstract classes, inner classes in abstract classes. We can also declare inner classes in abstract classes and which can be static member inner classes or non-static member inner classes. We can also declare inner classes in abstract classes and which can be static member inner classes or non-static member inner classes. Static member inner classes or non-static member inner classes. Now, let me write one program based on this. Right. See there. I am taking one project. Inner classes 4. I will take it. Application. Inner classes 4. I am taking. P1, P2. Package P1 and package P2. Under P1, I am taking one interface. Always I'll take iTest. I will take. Anyway, the variables what are available in the outer interface here, they are automatically static, automatically final, int sum a is equal to 10. So this is outer interface. Here. I am taking one class. I'm taking one class. Public, I'm taking. So public, automatically static class, subclass 1, I'm taking. Static member inner class. Public void M1. System dot out dot println. M1 method we are printing. That M1 method is trying to access outer interface. Outer interface A. Answer coming, no? Right, okay. Now, inner class object, very easy to create because it is a static, no? Very easy to create. Go for main class. So, demo. Inner classes 4. Inner class 4. So import p1 dot star. Inner class in interface. So how the object now? Sir, I test dot subclass 1 ob1 equal to I test dot subclass 1, because static means you can create like this, ob1 dot m. So the answer will come. Answer is coming now, right? In Java 8 version, default methods came now. Default methods came. Default, not class, method, void display 1. I am taking one static method came now. Static void display 2. Static methods came. Now here I am writing a class. Class subclass 2. I am writing a class. This local inner class no. Esa no na. Class subclass 3. So this also local inner class. This local inner class having one method, public void m2, one method. Local inner class here, public void m3, one method. Now system dot out dot print ln m2 I am printing. This m2 is trying to access that a variable. System dot out dot print ln. Outer interface a plus a. Now system dot out dot print ln m3. So system dot out dot print ln outer interface a. Wherever the local inner class is there only object available no. Yes or no na. Subclass 2 ob2 is equal to new subclass 2 and ob2 dot m2. Subclass 3 ob3 is equal to new subclass 3. So ob3 dot m3. All of you got it? Right. Okay. Now, I want to call a method. Sir, you can call I test dot display 2. You can call it. mean, there is a static method, you can call it. Sir, how you will call instance method? Whenever you want to call instance method, actually, right? This is for inner class object. So you cannot call OB1 dot display, you cannot call. So you have to create object. How you'll create object now? I test some OB equal to new I test. I'll write empty body here. What is this empty body? What is that empty body? Anonymous inner class with no members. Understood or not understood? Wow. This is interface now. This is interface now. Right. This is body now. This body is what now? Anonymous inner class or not now? With means no methods. Means no methods, we can say. No members. Best word is no members. Why no members? If any abstract method is there, I can write body. No members. I can write like this, no? Says or no na? OB dot display one. The answer will come. Right. Anyway, I'll explain this again to you. I written. So this topic I'll explain tomorrow to you. Up to here, I'll add the notes better. Inner classes, I'll explain again tomorrow. Okay, right. Yesterday's notes attached now, forget it. Attached? Right. This tomorrow I'll train this for you. Once again, I'll explain bit clearly. Time is very less, no, you cannot concentrate. Tomorrow I'll explain that how the syntax taken. Up to here, try this assignment and come. All of you with lambda. Try this today and come. Okay, right. Take a break. Thank you very much for today.